In the space of science and colossal secrets, the subject of what existed beforehand, prior to the enormous blast, has sparked mixed discussions and intrigued characters for a long time. This colossal question doesn't simply test how we could unravel the universe. It challenges the very limits of human knowledge. Envision standing at the edge of existence, investigating the enormous shadow, and considering what lay there before our universe was conceived. The event of the Big Bang marked the dawn of history, space, and all that we know. But was there a moment before this? Could something have existed beforehand? Could there have been a state of nothingness, a quiet before the grand cosmic gathering began? If this is true, what was it? Or perhaps there was something far more profound that existed before time itself. As we delve further into this inquiry, science takes us on a journey past the universe's starting point and into contemplations that challenge our awareness. Physicist Brian Cox, known for his contributions to understanding the wonders of the universe, proposes that something astounding could have existed before the Big Bang. He urges us to rethink our perception of reality and existence. In this assessment, we will dissect the science, hypotheses, and profound mysteries that may help us understand what existed before everything. We will explore considerations like divine intervention, quantum changes, dark energy, and even multiverses. The responses we uncover may astonish you, but they could also open new understandings of our place in the universe. Prepare to dive deep into a realm beyond imagination and science, where darkness still winds through the shadows, leaving researchers astounded and, at times, disturbed. Let us investigate what existed before the Big Bang and why these speculations challenge all that we thought we knew. To appreciate what might have existed before the Big Bang, we first need to examine what the Big Bang really was. The Big Bang, as researchers define it, refers to the moment when the universe became incredibly hot and dense, expanding rapidly to initiate the formation of all matter, energy, and forces. When we look toward the night sky, we see evidence of this hot beginning, with galaxies spreading out from a common point. But why did this happen? Was there a time before this dense, hot origin? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or serene. Cosmic inflation suggests that before the Big Bang, the universe was in a cold, empty, and free state, essentially a vast vacuum. However, this vacuum wasn't entirely empty. It contained a colossal amount of energy that powered the rapid expansion of space itself. This expansion, called inflation, occurred so quickly that it fundamentally set the stage for all that would follow. In a fraction of a second, space expanded at incredible rates until inflation slowed and the energy transformed into matter particles and forces, giving rise to the Big Bang. But what was the nature of this energy? Why did it suddenly expand the universe? And why did it stop? Experts believe that this limitless expansion created patches of the universe, each experiencing its own Big Bang. Envision a fabric expanding endlessly with tiny bubbles forming here and there, each bubble representing a universe, including our own. This idea, called the inflationary multiverse, suggests that there are potentially countless Big Bangs and an infinite number of universes. Ours is just one among many. This vast, mind-bending reality challenges our understanding of the universe itself and raises the question, what else is out there? The idea of nothingness before the Big Bang is, yet for our current understanding, even if we were to eliminate all energy, particles, and radiation from the universe, it would still not be truly void. Our universe is filled with dark matter, dark energy, quantum fields, and various forces that weave a complex tapestry of something, even in its most empty form. Even if we imagine stripping away all these forces, leaving a dead space, the universe would still generate new forms of energy. This puzzling reality suggests that absolute nothingness may be inconceivable within the bounds of our understanding. Space itself has properties, rules, and constants that prevent it from being entirely empty. Imagine creating a region with literally nothing in it. No particles, no radiation, and no energy. Yet quantum fields and fundamental constants would still exist. This implies that nothingness has properties. For example, there is a phenomenon called zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can momentarily appear and disappear, creating a faint echo of activity even in what should be empty space. This challenges the concept of a true void and suggests that, even before the Big Bang, there was something that scientists are only beginning to comprehend. One of the most fascinating hypotheses in modern cosmology is the possibility of eternal inflation. If inflation could create our universe, it is conceivable that it could continue indefinitely. Brian Cox describes an unimaginably vast inflationary multiverse, where universes are constantly being created and continue expanding. Imagine each Big Bang as a spark igniting another universe while inflation proceeds in other regions, creating countless new universes. This process could theoretically go on forever. This concept of infinite universes birthing others leads to the captivating idea of a fractal universe, where each new universe may create its own Big Bang. Each universe exists as a separate independent space, unaffected by others due to the rapid expansion of space. For scientists, this hypothesis is both exhilarating and unsettling, as it suggests an endless multiverse with no definitive beginning or end. Imagine our universe as just a speck in a vast, infinite cosmic structure, always expanding and continuously creating new universes. And what if the disturbing truth is that there is no before or after, but rather an eternal cycle of universes forming and decaying? Our understanding of nothingness changes when we consider quantum field theory. According to this theory, the universe is not simply a collection of matter floating in space, but a complex network of energy fields that permeate the cosmos. These fields are like invisible seas, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they remain active. Particles can appear and vanish in these fields, briefly borrowing energy before returning it. This phenomenon gives rise to virtual particles, entities that exist momentarily and then disappear, leaving only a faint memory of their presence. The concept of virtual particles challenges the idea of a true void. Imagine an empty universe stripped of all matter, radiation, and energy. Would you truly have nothing? Quantum field theory suggests otherwise. Even in a vacuum, fields remain active, occasionally producing fleeting particles. This constant activity in what should be nothing implies that the universe does not recognize our idea of emptiness. The fields and forces persist, filling the universe with a hidden energy that defies the concept of absolute nothingness. This raises a profound question. If quantum fields can create particles, and particles can create matter, could the universe itself have emerged from this nothingness filled with quantum fields? Dark energy is another mysterious force that not only shapes the present universe, but may also hold clues to what existed before the Big Bang. Dark energy is responsible for the accelerated expansion of the universe, but its origins remain elusive. Some scientists speculate that dark energy, or something resembling it, may have existed in a more potent form before the Big Bang. This stronger form of dark energy might have driven the inflationary phase, causing the universe to expand at incredible speeds. If dark energy existed before the Big Bang, it could have created the conditions necessary for the universe to come into existence. In this sense, dark energy could be seen as the silent architect of inflation, or even the key force behind the birth of the universe. The implications of dark energy go even further. If dark energy can influence the expansion of space-time today, it may have been a fundamental part of whatever process created our universe, and perhaps other universes. This idea opens the door to viewing dark energy not merely as a cosmic force, but as a bridge to understanding the multiverse itself. Another fascinating hypothesis is cyclic cosmology, which offers an alternative to the Big Bang as a one-time event. Cyclic cosmology suggests that the universe goes through vast cycles of birth, death, and rebirth. According to this model, the Big Bang was not the ultimate beginning, but rather part of an eternal cycle where universes expand, collapse, and re-emerge. This hypothesis implies that there was never a true beginning, just a never-ending sequence of universes arising, evolving, and renewing themselves. If this is true, what existed before the Big Bang was simply another universe in a different form, one that contracted until it reached a point of critical density and gave rise to the Big Bang. Cyclic cosmology also challenges our understanding of time. It suggests that time may not be linear, but instead cyclical, repeating endlessly. If this hypothesis is correct, it could mean that the universe has always existed in some form, transcending our ideas of beginnings and endings. Gravitational waves provide another intriguing clue. These ripples in space-time, caused by massive cosmic events like colliding black holes, may carry information from the universe's earliest moments, or even from before the Big Bang. Some scientists believe that if gravitational waves were created before the Big Bang, they could reveal the nature of the events that preceded it. The discovery of gravitational waves in 2015 has already revolutionized our understanding of the universe, but their potential to provide evidence of a pre-Big Bang state is even more profound. If we could detect such signals, we might uncover the remnants of a time before time itself. Through this journey into the unknown, we find ourselves confronting the limits of what is comprehensible. Was there something before the Big Bang? If so, what was it? These questions push the boundaries of science and philosophy alike. As we explore these possibilities, we are not merely uncovering the past. We are also pondering the future. The quest to understand the universe's origins, whether through quantum fluctuations, cyclic patterns, or the mysteries of dark energy, may ultimately transform our understanding of existence itself. This journey into the unknown reflects the boundless curiosity of humanity and our relentless desire to unveil the hidden truths of the cosmos. As we stand on the edge of what is known, we realize that the universe's secrets may forever lie just beyond our reach. Or perhaps, one day, we will discover that before the Big Bang, the universe was merely one stage in an eternal cycle of creation, destruction, and renewal.